Law of cosines. We just learned about the cases where we had to use the law of sines, including angle side angle or side side angle. We knew that we always had to have an angle and the side opposite. Now to use the law of cosines, we're not going to have an angle and the side opposite. So we're either going to have two sides and the included angle, which would be side angle side, or we're going to have three sides, so all three sides of the triangle. Now, depending on which angles and which sides we know, we are going to use one of these formats. So this is the standard form for law of cosines, and this is just an adjusted form solving for the cosine of the angle. So whether or not you're solving for a side or for an angle may well determine which format you're going to use. For instance, if I'm trying to solve for the angle, I'm probably going to use one of these, because then at the end of the question, I'm just going to take the inverse cosine of whatever I get on the right-hand side of my equation. But if I'm trying to solve for a side, then I'm going to use one of the standard forms of the equation. So let's take a look at how this is used to solve a triangle. For our first example, we're given all three sides and we need to solve the triangle, meaning we need to find all three missing angles. Because I'm solving for an angle instead of a side, I'm going to choose this format. You could get the correct answer using either format, but this one makes more sense for this particular question. Now, when you're determining which angle to solve for first, it's customary to begin with the angle opposite the longest side. So we're going to use b. Cosine of b is equal to a squared plus c squared minus b squared over 2ac. So I'm just going to take that formula. I'm going to replace a with 8, b with 19, and c with 14. And you can see that I would get cosine of b is equal to negative 101 divided by 224. To solve, I'm just going to take the inverse cosine on each side, and that is going to give me that b is about 116.8 degrees. 116.8. Now from here, I could use the law of cosines again, but the law of cosines is more work. So now, once I have found one angle and I have the side opposite, I'm now just going to switch to the law of sines, which we just learned in our last video. So I'm going to choose to solve for a next. So 8, which is the side opposite angle a, divided by the sine of a is equal to 19 divided by the sine of 116.8. So I'm using this as my known ratio. Then from here, I'm going to cross multiply. I get sine of a is equal to 8 times the sine of 116.8 degrees divided by 19. I would have to take the inverse sine of each side in order to solve for the angle. And again, I recommend that you leave it just like this. So a lot of students make the mistake of rounding this answer and then using the inverse sine of some rounded value, and you don't get the exact values when you do that. So taking the inverse sine, I would then get 22.08. So that gives me angle A, 22.08. And remember, when we're asked to solve a triangle, it means find all of the missing sides. The third this third angle is quite easy because we know they add up to 180 degrees. So I find that the measure of angle C is 41.12 degrees. Let's take a look at another example question. This one is a story problem. I would like you to try this question on your own if you're feeling up for it. And when you're ready, press play to see how you did. So to begin, we're trying to approximate the length of a marsh. So we walk 250 meters up to point B, turn 75 degrees, walk 220 meters to point C, and now we're going to try to find the length of the marsh based on the distances that we've walked. So we're looking for that third side. And because I'm looking for the third side, this is the format that I'm going to use. I'm going to use b squared, which is the side that I'm trying to find, is b. So b squared is equal to a squared plus c squared minus 2ac cosine of B. So now I'm going to replace A with 220, C with 250, and angle B with 105. Now that's very important because this angle was 75 degrees, so the angle on the interior is the supplement of that. So 180 minus 75 is 105 degrees. So now I have cosine of 105. From here, I'm just going to simplify as much as I'm able and find that B squared is equal to 139,370 and 95 thousandths. And then I'm going to take the square root of that to find that B is about 373.32 meters. The last thing we want to do dealing with the sides of a triangle is to find the area. Now we, in our last video, learned how to find the value of h, which was the height or altitude of the triangle, to find the area of a triangle, which is essentially taking the area equals 1/2 base times height and just adjusting that a little bit. But there is another way if we know the three sides. And again, this ties into law of cosines because we would use the law of cosines if we knew the three sides. So this is called Heron's formula. And what we're going to do is first we're going to find the semi-perimeter, which is A plus B plus C divided by 2. So that's S in our Heron's formula. A plus B plus C divided by 2. And then that is going to be the first value in our product, and then we're going to take that value and subtract each of the three sides to find the area of the triangle. So to begin, I would find S. That's 43 plus 72 plus 53 divided by 2, which is the perimeter of 168 divided by 2. And dividing by 2 gives us the semi-perimeter, so that's 84. So 84 is going to be our S value. So I'm going to take 84, and then I'm going to take 84 and subtract each of the sides. So 84 minus A, which is 43, 84 minus B, which is 72, and 84 minus C, which is 53. From there, I'm simply going to simplify by subtracting, and then I'm going to multiply and take the square root. So this area is approximately 1,131.89 square meters. Coming up next is section 6.3, which is vectors in the plane.